So if we're going to build AI that we can actually trust, with the big important stuff, it's not just about making it smart. It turns out building trustworthy AI really rests on three core ideas, three pillars. So let's dive right in and unpack what they are.
And here they are: fairness, explainability, and privacy. I want you to think of these as the legs of a stool. If any one of them is shaky, the whole thing comes crashing down. And we're talking about AI that makes really high-stakes decisions about our lives. Things like who gets a loan, who gets that job interview, or even how doctors make a diagnosis. But here's the catch, and this is really the whole puzzle we're exploring today. What happens when making the AI more fair actually makes it less private? Or when making it easier to explain makes it less fair? This is where our best intentions start to seriously clash.
Okay, so before we can really dig into those conflicts, we all need to be on the same page. So let's just take a second and define what we actually mean when we say fairness, explainability, and privacy.
First up, fairness. At its heart, this is all about making sure an AI system isn't just repeating the same harmful biases that exist in the real world. It's about fighting discrimination based on things like gender or race or age, so that the outcomes are equitable for everybody. Next, we've got explainability. Now, this is our window into the black box. It's our ability to actually understand the internal logic of a model, to get an answer to that really basic question: how did the machine make that decision?
And here's a really sharp distinction that organizations like NIST are making. Explainability tells us how the gears turned inside the machine, but interpretability, well, that tells us why we should care. It translates the technical how into a meaningful why for an actual person. Huge difference.
And our third and final pillar is privacy. And this one is personal. It's about protecting our data. When a model is trained on information about all of us, we have to make sure that no one can just reverse engineer it and pull out my specific private details. It's really about protecting our dignity. All right, so now we know what our three pillars are. But here's where it gets super interesting and kind of messy. They don't always stand together in perfect harmony. More often than not, they form this triangle of tension, where trying to do the right thing in one area pulls you away from another. So let's look at the first conflict: fairness versus privacy. Just think about it. Say you want to check if a hiring algorithm is biased against women. What do you absolutely have to know? Well, you need to know the gender of the applicants. And boom, right there is the problem. To check for fairness, you need the exact sensitive data that privacy regulations tell you to protect. It's a real catch-22.
And this quote from some recent research really hits home a painful truth here. When we try to enforce fairness, especially for smaller groups that are underrepresented in the data, those individuals actually become more identifiable. Their data stands out, which makes them easier targets for privacy attacks. So the very act of trying to protect a group can put them at greater risk. The cost of privacy isn't shared equally at all.
Okay, now for the second side of our triangle: explainability versus privacy. These two are almost natural enemies. To make a model explainable, you have to peel back the layers and show how it works. But the more you reveal, the more you might accidentally give away clues about the private data it was trained on. It's a constant tug of war.
And this is not just some theoretical idea. Bad actors can literally weaponize a model's explanations. They can use the very transparency we built in to create trust to attack the model's privacy. They can run what are called membership inference attacks, which basically ask the model, hey, was John Smith's data in your training set? More explanation can, unfortunately, mean less privacy.
And that brings us to the last side of the triangle: fairness versus explainability. Now, you'd think a simpler model is better, because it's easier to explain, right? Like a basic decision tree. But here's the problem. Deep, systemic societal bias is, well, it's not simple. And sometimes fixing that bias requires really complex, almost unexplainable models. So the fairest model might be the hardest one to understand.
And get this, here's a crazy twist: the explanations themselves can be unfair. Research has shown that the quality of the explanation can actually be worse for people from minority groups. And even more sinister, explanations can be deliberately manipulated to hide bias. It's a practice called fairwashing, where you cook up a nice-sounding explanation to cover up the fact that the model is actually doing something discriminatory.
Okay, I know, that's a whole lot of conflict and tension. It can feel a little hopeless. But the good news is, people aren't just throwing up their hands. Researchers and engineers are building out a whole toolkit to help us navigate these trade-offs. So let's look at some of the tools they're using.
When it comes to fairness, you can't fix what you can't see. So the first step is always measurement. And there are these amazing open source toolkits to help. You've got things like IBM's AI Fairness 360, which has something like 70 different ways to measure bias. Then there's Microsoft's Fair Learn, which is all about closing those unfair gaps between different groups. And Google's What If tool lets you visually poke and prod a model asking, hey, what if this person was different? How would the prediction change?
Now for privacy, the gold standard in the field is a really cool technique called differential privacy. The idea behind it is actually pretty brilliant. First, you make sure no single person's data can have too much influence on the final model. Then, you inject a tiny, carefully measured amount of statistical noise. Just enough randomness to make it mathematically impossible for anyone to be sure if your specific data was included or not. It's like creating a perfect crowd to hide in. But here's the thing. Privacy isn't just an on-off switch. It's more like a dimmer switch. Its strength is measured with this little Greek letter called epsilon. A really low epsilon means super strong, ironclad privacy. A higher epsilon is a bit weaker, but it might let you have a more accurate model. So surprise, surprise, it's another trade-off that developers have to balance.
And finally, for explainability. I mean, how do you even know if an explanation is any good? Well, this is a huge area of research right now, especially with regulations like the EU's AI Act coming online. But the consensus is that a good explanation has to be focused on risk. Does it help us spot potential harm? It needs to work for any kind of AI model, not just one type, and it's got to be useful to everyone, from the coders to the regulators to you and me. And most of all, it just has to make sense.
So after going through all of this, what's the big takeaway? The main thing to remember is that building responsible AI isn't about finding some single perfect solution. It's all about making a conscious choice to manage these trade-offs.
Which brings us right back to our triangle. See, the goal isn't to build each pillar, fairness, explainability, and privacy, as high as it can possibly go. That's impossible. The real goal is to find a stable, sensible balance between them. Because the right balance for a Netflix recommender is going to be totally different from the right balance for an AI that helps diagnose cancer. Context is everything.
And this really leaves us with one final and I think really important question. This isn't just a technical problem for a bunch of engineers to solve in a lab. It's a societal question. It's for all of us. As these systems become a bigger part of our lives, we all have to ask, which trade-offs are we as a society willing to accept? And in what situations? That's the real conversation we all need to start having.